this lesson, we're going to talk about operations with radical expressions. Pretty much what we're going to do is we're going to add, subtract, multiply, and divide expressions with radicals. In order to do so, the first thing we have to understand is what are like radicals. So like radicals are radicals with the same radicand. Now remember, the thing under the square root is the radicand. So in order to add or subtract radicals, they must be like radicals. In some ways, you can almost think of the radicals the same way you would a variable. So for this example, we have 4 root 3 plus root 3 minus 9 root 3. You can think of this in the same way you would think of it as 4x plus x minus 9x. Notice these are all root 3s, so they're all the same. So therefore, we would just add them or subtract them the way we would if they were x's. So 4 plus 1 would be 5. 5 minus 9 would be negative 4x. But remember, they weren't x's, they were root 3s. So we just swap that negative 4 root 3 right back in. For example B, if we look, they're all 2x's. So we can just write down the square root of 2x. And then from there, we just combine the numbers. 4 plus 3 is 7. 7 minus 5 is 2. So our answer is 2 root x. Sometimes you have to simplify before you can combine radicals. If we look at this example, I have 8 root 5, 2 root 45, and root 20. They are not like radicals, so I can't do anything with them the way they look right now, but maybe I can simplify. 45 would be the square root of 9 times the square root of 5, because 9 times 5 is 45. And then 20, we can make that the square root of 4 times the square root of 5. In our next step, I have 8 root 5, just copying that down, minus 2 times, now instead of the root 45, the square root of 9 is 3, and then I copy down the root 5 because that doesn't simplify. Then for the back part, the root 20 is just going to be plus, the square root of 4 is 2, and we copy down the root 5. Before we continue with the adding and subtracting, we first have to do 2 times 3 here. So we get 8 root 5 minus 6 root 5 plus 2 root 5. Now, they are all root 5, so we can write that down first. And now just combine the numbers. 8 minus 6 is 2. 2 plus 2 is 4. So our answer is 4 root 5. 75 would be the square root of 25 times the square root of 3. 27 would be the square root of 9 times the square root of 3. And 12 would be the square root of 4 times the square root of 3. So now to simplify, the square root of 75, 25 is a perfect square, so we make that 5 root 3. Minus the 4 gets copied down. The square root of 9 is 3, and then we bring down the root 3. Plus 9 times the square root of 4 is 2. Copy down the root 3. Before we can do anything else, we have to multiply. 5 root 3 minus 12 root 3 plus 18 root 3. 5 minus 12 would be negative 7 root 3 plus 18 root 3. I can keep the root 3 because that's not going to change. Negative 7 plus 18 would be 11. So our answer is 11 root 3. Now, when we multiply, we don't have to have like radicals. So when we multiply, the rule is it's the coefficient times the coefficient, radicand times radicand. If we look at our first example, I have root 5 times root 3. Since they are both under the square roots, we multiply them together and make it root 15. Plus, now when I distribute, there's really a 1 hiding in front of the 5. So 1 times 2 would be 2. And then 5 times 7 would be root 35. 15 and 35, they're not perfect squares. They don't have any perfect square factors, so we're done. We can't combine anything. We just multiply it and leave it. For B, when I distribute the 2 root 6, 2 times 3 is 6, and then root 6 times root 2 will give us root 12. Then I do the same thing here, so 2 times 4, so minus 8 root 6 times 10 is 60. Now, I know that 4 is a perfect square, and 4 goes into 12 3 times. Now, 60, does 4 go into 60? 4 does go into 60. So 4 times 15 is 60. So now when I keep simplifying, I copy down the 6. The square root of 4 is 2. Copy down the root 3. Bring down the minus 8. The square root of 4 is 2. Copy down the root 15. 6 times 2 is 12 root 3. Minus 8 times 2 is 16 root 15. And the 3 and the 15 are not the same, so we stop here. Now we have essentially a binomial times a binomial, so we could FOIL. Okay, we could do that. We could also make the grid. Remember when we multiplied, we made the grid sometimes? So we could do 2 root 5 from this first binomial. And then across the top, we could do 8 and then a negative root 3 for the second one here. So when I multiply them together, 2 times 8 is 16. 2 times negative root 3. Well, root 3 is under a radical, 2 is not. So I just make it negative 2 root 3. We just kind of mush them. The same thing happens for the 8 root 5. And then the last one is negative, because that's a negative sign. And then they're both under the radical, so we get root 15. And then we just write them all out in a row. So 16 minus 2 root 3 plus 8 root 5 minus root 15. None of these simplify, so we put a box around it and we're done. So for D, you can do D the same way, or you can FOIL, just distributing the 2 and then the negative root 7. Okay, so I think I'm going to do the box again. So I'll have a 2 and then negative root 7, and across the top 2 and positive root 7. 2 times 2 is 4. 2 times root 7 would just be 2 root 7. We just kind of mush them. Here would be 2 and negative root 7, so negative 2 root 7. And then root 7 times root 7 would actually be just negative 7 because the 2 square roots cancel out. Now, when I look at what's in my box, 2 root 7 and negative 2 root 7 cancel, so we get 4 minus 7, which would be negative 3. Did anybody notice that these are conjugates? Remember, we've talked about conjugates before. Conjugates happen when we have the identical terms, so they're both 2's, and then they're both root 7's, but the sign in the middle is different. So this one's negative and this one's positive. The shortcut for conjugates is just first times first, so 4, and then last times last, minus 7, which is negative 3. So if you recognize that those were conjugates, you could do that shortcut. Here's the definition of conjugate, the sum and difference of the same two terms. So that's what we just had here. One was a plus, one was a minus, and then the two terms were the same. See here? So what happens when we multiply conjugates together? Well, when you saw up here, the radicals cancel out. Now, this is super important because sometimes we have to rationalize the denominator. When we rationalize the denominator, that means no radicals in the denominator. Now, we do this using conjugates. So I have root 2 minus root 7. So we multiply by root 2 plus root 7. And we do that on the top and the bottom. Because as long as it's the same on the top and on the bottom, it's technically equal to 1. So we're not changing the value of this fraction. So I'll start by distributing the top. So 8 times root 2 is just 8 root 2. And then plus 8 root 7. And then for the bottom, they're conjugates, so we can use the first last shortcut. Root 2 times root 2 is just 2. A negative times a positive is a negative. Root 7 times 7 is 7. So the top stays 8 root 2 plus 8 root 7. The bottom becomes negative 5. You can leave it like this. I would mark it correct. However, if you want to move big leagues, okay, remember we can take stuff up a notch sometimes and go to the big leagues. So in the big leagues, we don't like to have a negative in the denominator. We want just a positive 5. So what we can do is we can change the signs of everything on the top. So essentially what we're doing is we're doing 8 divided by negative 1 is a negative 8. And the same thing here, 8 divided by negative 1 is a negative 8. So this is the big league answer, okay? With the 5 being positive. I will also accept the 5 being negative. That's fine. Ratio length to width of a painting is approximately equal to the golden ratio, 1 plus root 5 to 2. For an interesting little thing, look up the golden ratio, and then you'll find some really cool stuff there. The length of the painting is 51 inches. Find the exact width of the painting in simplest radical form, then approximate the width to the nearest inch. So length to width. Okay, we're going to put length on top, width on the bottom. So the length is 1 plus root 5. The width will be 2. And that has to equal, they say the length of the painting is 51. Find the width. So we do x. So now to solve this, we cross multiply. So x times 1 plus root 5 equals 102. Now, to get x by itself, we divide by 1 plus root 5. So x is 102 divided by 1 plus root 5. Now, let's go ahead and rationalize this. So I'm going to multiply by the conjugate, so 1 minus root 5. When I distribute the top, I get 102 minus 102 root 5. The bottom, 1 times 1 is 1. Positive root 5 times negative root 5 would be negative 5. So this is negative 4. Now, I think 102 might be divisible by 4, so let's check that. 102 divided by 4 is not, I lied, but we can divide everything by 2, okay? And while we're at it, let's divide everything by a negative 2 to go big leagues and get that negative sign out of the bottom. So 102 divided by negative 2 would be negative 51 plus 51 root 5 over 2. So this would be our exact answer. Now, something super important happened here. Okay, I could only simplify because 102 and 102 all shared a common factor. If they didn't all share a common factor, then we would not have been able to simplify. Okay, so all 3 numbers have to share that common factor to simplify. So that's the width of the painting in simplest radical form. Okay, now the approximate width to the nearest inch, we're just going to type this in our calculator. So in the calculator, we will type in negative 51 plus 51 root 5. Now it's best if we hit enter there and then do divided by 2. So I get 31.5197. They want the nearest inch. So the nearest inch would be approximately 32 inches. This next page is a whole bunch of practice that we may or may not do together, but if you would like to work on some of these on your own, you are more than welcome to.